All right, so we're going to move to the next part of our show, and this is actually my favorite part of the Developers Conference, because now you're not just going to hear from Lattice experts on the technology inflection points in the industry. You're going to hear from industry experts on what's happening in some of these technology inflection points. So it's my pleasure to introduce our next guest speaker. From NVIDIA, Head of Embedded AI Project Management, please give a warm welcome to Amit Goel.
Thanks for the introduction. Thank you all for joining today. I'm glad to be here in Lattice's first developer conference. And it's a really exciting time to be in this industry. So I'll be talking a little bit about the work we are doing together with Lattice to bring low latency I/O for edge intelligence. First, let's look at what's happening in the industry. AI, which started in data centers with large CSPs and consumer internet companies, is now making its way into mainstream applications. We are seeing a huge adoption of AI on the edge in large industries, several $7 trillion worth of value to be created through innovation with edge AI in these industries. So let's take a look at a few of them. Manufacturing is one of those areas where we are seeing a huge improvement from smart factory and automation, whether it's things like logistics or quality inspection of parts. In retail, we are seeing applications from autonomous checkout to reducing shrinkage and theft, improving customer behavior and analytics. In smart cities, we are seeing improvements being made to our safety, the traffic, as well as energy efficiency of how we are operating our facilities. Healthcare is another major area where edge AI is making a big difference. Everything from surgical robots to equipment like ultrasound and endoscopy are all incorporating AI to improve the outcomes. Logistics is another big industry which saw a huge benefit from edge AI. As COVID happened last few years, the logistics industry was severely strained, and automation was extremely important to make all the products delivered to our houses. So e-commerce, warehouses, all of them heavily adopted AI to accelerate the smart picking and delivery of products. As we all know, the demand for labor in agriculture is a big problem. We have a lot more food to produce and a lot less people to make it. So agriculture industry has been adopting AI a lot to bring precision farming so that our farms can be more efficient and our yields can be better and our products can be delivered in a cheaper way. In home, everything from health, providing care to our elderly to keeping our kids busy, AI is helping a lot. And the last one is in metals and minings. Again, an area where it's a very dull, dangerous job. And by infusing AI into those machines, we are seeing huge improvements in efficiency as well as safety. So we all here know that edge AI is important, but I wanted to give a few numbers that put a light on why exactly are we seeing more and more compute demand on the edge. The first example is for a self-driving delivery robot that might be going on an aisle. And for a 3-camera and a single LiDAR, which is a very modest sensor configuration, the system generates 2 gigabytes or more per minute of data. There is no way you can transmit this data and act on it in real time. The second example is from a tractor from John Deere, where the tractor moves at 12 miles per hour. If you try to look down from your car or your vehicle moving at 12 miles per hour, extremely hard to even see what's going by below you. But this tractor has to look at 36 cameras, scan an area of 2,100 square foot at each instance, and make a decision where and when to spray. So this requires extremely low latency that can only be done if you're processing all of this and doing this on the edge. And the last one is a typical example of a video analytics use case where you might be having to detect a person or a vehicle. And if you have several hundred cameras that want to send a request of a few seconds every hour or a few minutes every day, then it's fine to send all the data to the cloud. But if this camera needs to process this 24/7, every second, you see the cost of transmitting, the cost of storage, the cost of inference in the cloud really adds up. So thousands of cameras, each doing 2 inferences per day, great, send it to the cloud. But you have one camera that is doing tens of thousands of inferences per day, you want to do it on the edge, right? So cost, latency, bandwidth, very big reasons to drive more and more compute and AI at the edge. So to solve this problem of AI and to address it in a way that is scalable and serving this vast industry and applications, we purpose-built an SoC. This SoC has been purpose-built for advanced autonomous machines. And as you can see, it has a lot of different elements to it. The latest generation of our edge SoC is called the NVIDIA Orin. It has a mix of CPUs, GPUs, high-performance I/O interfaces, high-bandwidth memory, and a very rich I/O connectivity to enable these autonomous machines. So Orin has 12 A78 CPU cores. It's based on our latest Ampere GPU. So it has the same GPU that is available in a data center running LLMs is also available on the edge for you to deploy those workloads. And we have 256-bit LPDDR5 DRAM with 205 gigabytes per second of bandwidth. From a connectivity perspective, we have 10 gig Ethernet with over 22 PCIe lanes. And as you can see, this is not a general SoC. The balance of compute, serial compute with CPUs, balance of accelerated compute with GPUs, the memory bandwidth, the I/O, all of that has been very carefully designed to meet the demands of the edge AI applications. And it's no coincidence that when the transformers came, when the LLMs came, they can all run on the device today on Orin. But as you heard from the speakers before, the hardware is only as good as the software that's driving it. And I like to give the analogy of a sports car. The Ferrari by itself, you're not going to build you a Formula One. You need a Schumacher. You need a brain behind it to actually get you the win. So we invest heavily on our software stack all the way from the lowest level to the highest application level software. This one is quite an eye chart, but you can see that the work that we have to do and innovation, starting from operating system, securities, system level services, and then go layer by layer and develop the software so our developers can really accelerate their time to market. Our AI stack today is extensive. We have a pretty big ecosystem of partners that are providing support for the latest and greatest models that serve across industries. And we don't stop at just accelerating the libraries of the AI stack. We go one level above. As we see application in specific areas, we create application-specific vertical stacks. So there are two main stacks that we support today for the edge. One is called Metropolis for video analytics and sensor processing, and Isaac, which is for robotics. And combine this together with our offerings on the cloud, it becomes really easy to develop applications that span from edge to cloud. So what this has enabled us is to build this really democratized AI at the edge. We have over 1 million developers that are building AI applications on the edge with the platform. And this is, it gives me a lot of pride to say that from high school students all the way to Fortune 100 companies, they're able to leverage the same platform and develop AI at the edge. So everything is good, right? We've got the software, the hardware, millions of developers. So where is the problem? Why are we here? Well, over time, as we talk to developers and customers, we have learned that while we have really reduced the effort it takes to develop the AI application and software, the system-level hardware and integration has become a really large chunk of where they're spending their time. So this really slows down the time to market for the products. So we spoke to several of our customers and figured out that sensor interfacing, or developing the integration of the sensors, is one of the big challenges they face. And it's not surprising. The sensors, as you are not designed, at least most sensors are not designed to directly connect to the computers, right? So we looked at it, and we spoke to several customers, and we have found a pattern. The sensors have different interfaces: JSD, LVDS, MIPI, USB, Ethernet. So they have multiple different interfaces. They have physical constraints. They have different data formats. So it's not very easy to connect them. Most of our customers were working with FPGAs. They provide the flexibility, the low performance, the latency that is needed to connect these sensors to the compute. And to bring the data into the compute fabric, they were using either Ethernet or PCIe. So this was a trend that we observed, and we saw every customer was doing this over and over again, spending a lot of cycles building this. So today, we are pleased to announce that we have created, together with Lattice, a reference sensor bridge design. This design is a generic sensor interface that's going to enable developers to really build plug-and-play scalable, low latency, and high performance interface for your sensors. We have, at the core of this is a Lattice FPGA, which provides you the connectivity and for a wide variety of sensors. We have built an IP that can convert all of this and packetize both the data and the control plane, and connect it to the NVIDIA's Edge AI platforms, which is our AGX products, the Orin products, as well as our IGX products. So with this standardized sensor bridge design, we believe that connecting sensors to the compute, NVIDIA compute, is going to be really easy, and every customer will not have to go through the same effort over and over again, and really accelerate their development time. So let's, we are early access for this board, and reference design is available now. And we are targeting broad availability in the first half of 2024. So let's dig deep a little bit more into what is on this reference design. So on the FPGA side, we have an IP for Ethernet packetization. It's a full RTL-based implementation, so there is no CPU involved, which gives you extremely low power as well as high performance for this packetization interface. For connecting to the sensors, we have the AXI stream ports as well as APB control bus. And on the receiving end, the data is fully integrated with NVIDIA's IGX and AGX platforms. And one important thing about this reference design is we plan to make all the enablement IP that is needed for our partners and customers to interface their sensors. We plan to make this entire IP open source. So anything that you would need, you don't need to develop it on your own. We will provide you some references, and you can extend that for your own sensors. The second part of this partnership is the work that we had to do on our side on the compute stack, where we wanted to really abstract away the entire transport, the protocols, the connectivity between the FPGA and the Odin SoC. So we have developed a full software stack at the lowest level, starting from the Linux operating system. As mentioned, we have two different platforms that can support this sensor design. One is our AGX, and the other is IGX. On IGX platform, we have a smart NIC. So the data that's coming in can be, the packets can be processed with a smart NIC and directly sent into the GPU memory. And on the AGX, we connect them through the Linux sockets. On top of that is the transfer abstraction layer. The entire streaming DMA and the control interfaces from I2C, SPI, and GPIO are all available through a standard API. So you don't need to configure these for every new sensor that you are using with the platform. So as a sensor operator, you just use our predefined APIs, create your sensor driver, and start working on your end application. And this partnership is not just about bringing together NVIDIA and Lattice. What we're trying to do here together is bring two giant ecosystems as well. We heard about the growing ecosystem of Lattice partners, and on the Jetson and on our embedded edge side, we have a pretty huge ecosystem of partners, from sensors to hardware designers to ISVs building applications. And with this, combining these two ecosystems together, we'll build a network of networks that is really going to accelerate the time it takes to build edge AI applications. Finally, I hope I got most of you excited here about the work we are doing together. As I mentioned, we are in early access. We have the boards that we have given to a few of our customers. If you're interested in developing applications, please reach out to us. On marketing side, we have the contacts here for both Lattice and NVIDIA team. And if you want to see this thing working, we actually have a demonstration downstairs where you will see both the platforms connected to the sensor design and streaming live camera data. So thank you.